So for our first example today, we're going to revisit an example from the last section. Remember that this is a sample space or the possible outcomes of a student guessing on a four question true false quiz. And so in this scenario, for question one, they guessed incorrectly, 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 incorrectly. I means incorrect, C means correct. And then in this scenario, they guessed all four questions correctly. Okay? And then these are the different possibilities or combinations that you could come up with. In other words, this will be getting one question correct. These are the different combinations that you would get. Now, where that comes from is basically what I do is I go to my first question, all right, and I can guess correctly or incorrectly. So I'm either going to get the first question correct or incorrect. Then on the second question, I'm either going to get it correct or incorrect, or correct and incorrect. And then if you follow that pattern, what you'll end up with is this is where I get correct, 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 correct for all four questions. And then way over here I get incorrect, 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 incorrect. And so if you put all these possible combinations together, that's where you'll get this table from. So for our example today, though, what they want us to do is determine independence and dependent events. So the first thing that I want to do before we talk about that is determine what is an independent event. So an independent event, I always misspell that word wrong. Independent event is two events where one event does not affect the other. And so this is with regards to probability. Okay, so if I have two events, in other words, if I have the probability of an event A occurring and the probability of an event B occurring, then that should just be the probability of A times the probability of B. Okay? And so question number one, example number one says, and I'll read this out loud straight from the textbook, it says, a student taking a quiz randomly guesses the answers on 4 true-false questions. Use the sample space to determine whether or not guessing one correctly and guessing 2 correctly are independent events. So in this case, we're going to have 2 events, all right? Event A, the probability of A, question 1, correct. The probability of B, question 2, correct. All right? And the way that we could determine if they're independent or not is basically by looking at the sample space and then finding the probability of guessing question 1 correctly. And so what you could do, you could just count it. Well, first of all, in our sample space, remember from yesterday that we have 2 possibilities here, times 2 possibilities here, times 2 possibilities here, and 2 possibilities here. So our total outcomes was 16 outcomes. So the probability of A occurring, okay, is something out of 16. And we just have to go through and figure out what that probability is. And so if I go through here and I look at all these, in other words, what I'm going to do is I'm going to count all the scenarios where I have the first question correct, right? So I've got, basically, if I look here, I have, this is one possibility, this is another possibility. So I have 1, 2, 3, 4, 5, 6, 7, 8 possibilities where question 1 is correct. So that's the probability of event A occurring. So that would be 1/2. And then, because I get 8 out of 16. Alright? Now the probability of B is guessing that the second question is correct. So now, again, my sample space is 16. And we could look at the data, or we could just look at this probability tree. My second question being correct would be this one, right? So this would be my second question being correct. And so then if I come down here, it's everything that branches off of that. So there's 4 here. Or the second question being correct, again, that would be these 4 here that would branch out. Okay, and that would be 8. Now another way that you could do is you could just go through here and go, okay, here's one where the second question is correct. Here's another one where the second question is correct, second question. So I could just count those 1, 2, 3, 4, 5, 6, 7, 8. Okay, that reduces down to 1/2. Now, the probability that they're asking us is, what is the probability of both of them, questions 1 and 2, being correct? So now we could just find the sample space. In other words, we're looking for the first 2 letters to be correct. Again, the sample space is out of 16. There's 16 possible outcomes. Okay, so what we're doing is we're looking for the combinations where we have the first question is correct, the second question is correct. Alright, and then if you follow that down, you're just going to have these 4 possible combinations. Now if we were to look at the table or the sample space, what I'm looking for is CC. Alright, so it's got to be at least 2 correct. So there's 1, 2, 3, 4. I'm just looking, and what I did is this is correct. The first 2 questions are correct. So I've got 1, 2, 3, 4. So that means my probability of it being the first 2 questions correct would be 4. That reduces down to 1/4. Now we said that P, the probability of the first question being correct and the probability of the second question being correct would be the probability of the first being correct times the probability of the second being correct. If they're independent. Only if they're independent events. And so we've got 1/4, right? The probability of A and B, in other words, question 1 and 2 being correct, is 1 out of 4. But the probability of the first one being correct is 1/2 times the probability of the second question being correct, which is 1/2. And so yes, it's true. These are independent events because the math followed the formula. Now if they're dependent, I'll teach you a different method, but this is how you determine if 2 events are independent or dependent. In other words, it doesn't matter what they guess on the first one. There's no condition. They could get the first one correct just as much as they could get the second one correct. Those 2 events are completely independent of one another. And then mathematically, to calculate the probability, we would use this formula.